All right, so let's go through these things a little bit more in depth. So strength, what I said is the ability to overcome inertia. All right, so what we mean is you are going to take something that is at rest and you're going to provide energy to it. And that energy, that force that you put into it is really the force that's produced by your muscle. And what limits that force is what we talked about, the sarcomeres. Remember going back to those sarcomeres? If you had them in series, they could go fast. And if you had them in parallel, they would produce more force. So if you want to be very good at strength, you need to have lots of sarcomeres in parallel within your muscle. We also talked about how the muscle only functions when we recruit these big fast motor nerves. So our ability of our brain and our nerves to increase the contraction of these fast motor nerves and these big, huge muscle fibers, that's going to go into our strength. So if we can turn on the right nerves at the right time to be able to produce maximum amount of force within that muscle, we have lots of sarcomeres in parallel. Now, if we can recruit all of the muscle fibers within that muscle at one time, now we're going to have lots of strength. And the third thing that goes into strength is something that very few people really think about. That's the stiffness of the connective tissue. Because the greater the stiffness, the better you can transmit the force that thick and thin filaments are producing to the tendons to move the bones to provide the strength that you're looking for. So it's a lot like if I take a weight on my desk here and I attach a rubber band to it and I pull on the rubber band's just going to stretch. The weight's not going to move very far. That's not really good. That's not strength because we haven't overcome inertia. If I tie a rope to it now, the rope, I pull on it, if the weight is enough, the rope is going to stretch. But then because the rope has better stiffness, it's going to actually, once it's stretched a little bit, now it's going to move the weight. Now I've overcome the inertia of the weight. But if I attach instead a metal rod to that, as soon as my muscles produce force, now that force is immediately transmitted to the weight and I overcome the inertia of the weight. So if I'm stiffer, I can transmit the force better, and that means that I'm going to look stronger. All right, so that's strength. Power now is how quickly you can develop that strength. So yeah, you can turn on the right motor unit, or yeah, you've got lots of sarcomeres in parallel. But now what happens is we look to see whether those sarcomeres are in parallel. Are they filled with fast or slow myosin motor proteins? So if you have fast motor proteins within that muscle fiber that has lots of sarcomeres in parallel, that's big sarcomere, now if there's fast myosin in there, you can produce lots of force because it's got lots in parallel and it's got the fast motor unit, so you can really contract quickly. If you've got the right nerves, again, that's going to help you contract faster. Because if you have more fast motor units, you can contract those fast motor muscle fibers better than if you had slow motor units. Okay? The pennation angle of the fibers is now going to be important because power is going to be related to both the kind of, it's the physiological cross-section as well as the sarcomeres in series, because you need to have sarcomeres in series as well as sarcomeres in parallel here, because the more sarcomeres in series, the faster your contraction is, but you also need sarcomeres in parallel. And that's where lots of sarcomeres in series and then angling the fibers so that you have a pennation angle so that you get a bigger physiological cross-section is going to give you greater power. And now we can also say stiffness of the connective tissue, because again, if you've got really stiff connective tissue, as soon as you develop force, bang, it's transmitted to where you need it to go. All right, now let's talk about endurance. Endurance is the ability to maintain force, speed, or power. Okay, so what does that mean? Endurance is really about how well we use oxygen to produce ATP. And our maximal ability to produce energy using oxygen is called our VO2 max. Okay, our VO2 max is basically determined by how big our heart is, how much it can pump, and how much blood flow we get to the tissues the muscles that we're exercising. And then once you get to the muscles you're exercising, how many mitochondria do you have in those muscles? Those are the things that go into VO2 max. And we're going to spend a whole lecture really about this component of VO2 max and endurance. The second thing that goes into endurance is lactate threshold. And what lactate threshold is, it's your ability, this is the maximum velocity or the maximum power you can sustain. So this is what you can do without having to bring in those big, huge motor units that are going to have fewer mitochondria, that are going to generate more lactate and go at an energy using a force that you can't sustain for a long period of time. Because remember, those fast fatigable motor units fatigue quickly. So if you're above your lactate threshold, now you're bringing in those fast fatigable motor units. Now you're not going to be able to sustain that velocity for very long. A colleague of mine used to work with Haile Gebrselassie, who was one of the greatest marathon runners of all time. And Haile would sit there and he could get onto a treadmill and he could run 19 kilometers an hour. Woo! I couldn't run 19 kilometers, and he could go 19 kilometers an hour forever. 2-3 hours without a problem. But if he went up to 19.3 kilometers an hour, he would be exhausted within about 10-15 minutes because it was above his lactate threshold. I mean, he could dial it in that tightly. Okay, so above a certain speed or power, you're going to not be able to sustain that. And we all know that speed or power because we're like, okay, yeah, I'm running along here and I'm trying to pass this person and I know I can hold this for maybe a minute more, but I'm not going to be able to do this for 5 minutes, 10 minutes, 20 minutes. The last thing, again, is this thing called movement economy. And so our endurance is going to be limited by our movement economy. And that's basically how much energy we take to go a specific velocity or power. Okay, so think about it this way. If, again, this goes into how economical our structures are. So if we have long tendons and we have long legs, we're going to run more economically than if we had short legs and short tendons. If we're swimming and we have long legs, we're going to move poorly because, again, remember, swimming you want a long body and short legs. So the economy of the movement is relative to which movement we're doing. And so some different body shapes or different types of stiffnesses within your body are going to affect how economically you do a given movement. And so that, how economical you are at doing swimming or rowing or cycling, is going to have an impact as to your endurance. Okay, so your endurance, your ability to maintain force, speed, or power is determined by your VO2 max, lactate threshold, and your movement economy, how efficient you are at doing those movements.